All right, moving on with problem number 8 here. We see that we have two side lengths congruent, and we do have a shared side here, CA, that is congruent to itself. So we can go ahead and say that these two triangles are congruent by side, side, side. And if you want some extra practice, if I was writing these triangle congruencies out, I would have triangle CAN is congruent to, since I started with this angle up here, I need to start with angle A in my second triangle. So triangle ACO. Number 9. All right, in this picture here, I'm given a right triangle, and I have two sides, specifically a side length and a hypotenuse here. If I know I have a side length congruent to another side length and a hypotenuse congruent, and it is a right triangle, we can go ahead and say that these two triangles are congruent by HL. And our triangle statement would be triangle, oh, this label went away, so we're not going to do that this time. Okay, number 10. Number 10, again, I'm given two right triangles, so we should be thinking to ourselves, HL is probably the congruency. We're given a side length here, NP and YU, but we should also know that PA is congruent to UA in order to show that these two triangles are congruent by HL. So this would be not enough information. We need to know that PA is congruent to UA to show these two triangles are congruent by HL. That is what we need. Number 11. Number 11, we are given an angle that's congruent to an angle, another angle is congruent to another angle, and we've got a side length congruent to a side length. So I've got two angles and a side length. So that could be either ASA or AAS. We got to look and see what is the relation. I start with an angle, and then if I'm looking at it clockwise, my next thing is an angle, my next thing is a side length. So these two triangles are congruent by angle, angle, side. And if I were to write it out, get some practice with those triangle congruent statements, I'm going to start with angle APB is congruent to triangle RDI. And last one for this, number 12. I've got two right angles here, right angle and right angle. I know an angle up here and an angle right here. I also know that this side length is going to be congruent to itself. So I know these two triangles are going to be congruent by angle, side, angle, and our triangle congruent statement we cannot write because we are missing a letter there. All right, last one on this page here. We are going to look at the trapezoids to determine which of the following proportions show that they are similar. Circle all of the ones that apply. So we got to look at things that are similar here. So first one, I've got 27 over 36. Well, this is 27, this is 36, so automatically that one is not going to work. Okay. Next one, I have 24 over 36. Those things are similar. And then 27 over 40.5. That is similar as well, so this would be one. 36 to 40.5, 36 to 40.5, and 24 to 27. Again, those are in the similar positions, related, so we can go ahead and say that one's good. Next one, we've got 27 over 24, so I've got this side length over that side length. And then it should be the similar side length, so 40.5 and 36. That one would work as well. 27 over 40.5, those relate. 36 over 24. We started with this one, so we should start with 24 in my second fraction, so this one will not work. Next fraction, we've got 36 over 24, 36 here, 24 here. 27 over 40.5, if we started with 36, we should be starting with 40.5, so that one will not work. Next one, we've got 27 over 40.5, and then 24 over 36, that is good. 40.5 over 36, so we're starting in the same trapezoid, which means if we started with this side, we should start with 27 over 24. We did, so we are good for that one. And the last one, 24 over 27, we started in the same trapezoid, so my relation should be the same position in my second trapezoid, and in fact it is. So all of those ones highlighted in red are correct, and those ones that are crossed out would not work as proportions.